Hello students, good evening to all of you. Today we will solve the next problem based on the empirical formula and molecular formula. This problem is very important. Let's see the statement of the problem first. A compound on analysis gave the following percentage composition: sodium 14.31%, sulfur 9.97%, hydrogen 6.22%, and oxygen 69.5%. Calculate the molecular formula of the compound on the assumption that all hydrogen in the compound are present in combination with oxygen as water of crystallization. The molecular formula of the compound is 322 gram. Atomic mass is given: sodium, sulfur, hydrogen and oxygen. So first we will calculate the empirical formula, then we will calculate the molecular formula. Okay students, so let's see the solution. So for the calculation of the empirical formula, we have to follow this table. Okay students, so see, in this table these are the six columns: elements, percentage, atomic mass, moles of atom, and mole ratio and simplest whole ratio. Okay, so in the first column we will write the elements which are present in the organic compound or simply in compound. So in that compound only sodium is present, sulfur present, hydrogen and oxygen present. So we'll write the percentage. It is given in the question: sodium percentage 14.31% and sulfur 9.97%. Okay, hydrogen 6.22% and oxygen 69.5%. So these are the percentage are given students. Okay, now atomic mass of sodium is also given 23, sulfur 32, hydrogen 1 and oxygen 16. Okay, now we will calculate the moles of atom. For the calculation of moles of atom, we will divide the mass by atomic number. So here percentage of the element which is given in the question will act as the mass of the element. So sodium having the percentage 14.31%, so we will divide. For calculation of moles of atom, we will divide 14.31 by atomic mass, that is the 23. It will, after division, it will come 0.62. Students, already I done the roughly calculation in some other sheets, that's why I am writing directly here. Okay, you can also divide and do some rough work. 9.97 divided by 32. These are the moles of mass of sulfur, that is 9.97, and atomic mass 32. We'll divide. We will get after division, that is 0.31, and here mass of hydrogen is 6.22 divided by 1. We will get, this is the atomic number of atomic mass of hydrogen. We will get 6.22. Now we will divide the mass of oxygen by atomic mass 69.5 divided by 60 equal to 4.34. Okay, now students, what we will do, we will in next column we will calculate the mole ratio. For calculation of mole ratio, what we will do, we will see out of all the moles which is the smaller value. So if you see that here in this moles of sodium, sulfur, hydrogen and oxygen 0.31, these are the moles of sulfur are having the very small value. Okay, so by this smaller value we will divide by this number of moles we will divide the moles of all other elements, okay, including sulfur also, for finding out mole ratio. Okay, so here 0.62, these are the moles of sodium, will be divided by 0.31. We will get here 2. Here 0.31 divided by 0.31, we will get 1. 6.22 will divide by 0.31, we will get here 20. Okay, and 4.34 will divided by 0.31, we will get 14. So mole ratio here we got for sodium got 2, sulfur 1, hydrogen 20, oxygen 14, and this mole ratio will act as the simplest whole number ratio. Okay, if they are not in if these ratios are not in a whole number. So what we have to do, we will divide these mole ratio by suitable number, by suitable number, so that it can become whole number. But here already these are in a whole number, so no need to multiply it by any number. So what will be the empirical formula, students? So empirical formula equal to, here how many sodium are there? How many sodium are there? 2. So empirical formula will be Na2, how many sulfur are there? 1. Na2 sulfur 1, and how many hydrogen we got? 20. H 20, and how many oxygen? Oxygen 14. Okay. So simply these are the, this is the empirical formula of compound. Now we will calculate the empirical formula mass. Empirical formula mass. This will be useful for next step. So here 2 sodiums are there, 1 sulfur is there, plus 20 hydrogen there, and plus 14 oxygen is there. Okay. So 2 sodium, 1 sodium atomic mass equal to, that is 23, plus 1 sulfur 32, plus 20 plus 1 hydrogen 114 into 16. Okay, 16. This is the atomic mass of the oxygen. So after multiplying and adding, you will get 322. Okay, this is the empirical formula mass. Empirical formula mass. Okay. Now what we will do? Simply here, for the calculation of the step 2, we will calculate the molecular formula. Okay. So molecular formula equal to N into empirical formula. Here N we have to calculate. N equal to molecular mass upon empirical formula mass. So molecular mass, it is given in the question. How much it is given? 322. Empirical formula mass we already calculated here. You can see here in this sheet, that is 322 gram. So it is also 322. By dividing, we will get 1. N equal to 1. So molecular formula equal to 1 into empirical formula. What empirical formula? Na2S S20O14. Okay. So we'll get here molecular formula. Na2S H20O14. Okay. Up to this we got, but this is not the final answer, students. One thing is given in the condition. This is very important condition in this question given here. See, since all hydrogen atoms are present in combination with oxygen as water. Okay. Therefore, it means that all 20 hydrogen atoms must be combined with 10 oxygen atoms to form 10 molecules of water of crystallization. The remaining 4 oxygen atoms are present with compound. Thus, in that new molecular formula, that is final answer, molecular formula equal to Na2SO4 dot 10H2O. Okay, here 10 water crystallization will be present. So this is the final answer, students. Everything is well and well. Thank you. Have a good day.